Today we're going to continue our lecture on counting. So let's recall the setup that we have from the previous lecture. So we have two important numbers. R is the number of experiments and N is the number of distinguishable outcomes. So when we say experiments, the experiment could be flipping a coin. It could be dealing a card from a deck. It could be deciding whether or not to include a certain person on a team. It could be deciding whether or not to include a certain number in a subset of a given set. Okay, so we have lots of different experiments and they have distinguishable outcomes. So we want to know how many experiments will there be. So if I'm flipping a coin 10 times, that would be 10 experiments. Each single flip would constitute one experiment. And the number of distinguishable outcomes is how many outcomes do we have on each experiment. So in the case of flipping a coin, the N would be 2, heads and tails, 2 outcomes per coin flip. So could repeatedly roll a die, in which case N would be 6. That's 6 outcomes for rolling a normal 6-sided die. So another type of experiment would be dealing 5 cards from a deck. There R would be 5. Every individual card would be one experiment, and the outcome would be which card did you deal. So in that case, we would have N initially is 52. We have a usual deck, it has 52 cards. After I deal one card, then there are only 51 possible outcomes for the second card, and only 50 outcomes for the third card, etc. So here we have, if we want to take R and N and then count something, how many different, say, poker hands could I get? How many sequences of coin flip results could I get? We have to ask 2 questions. Does order matter, yes or no? And are we doing with replacement, yes or no? So with replacement means, well, so in the example of the cards, when I see, say, 4 of hearts once, right? So if somebody deals 4 of hearts to me, I know that none of the later cards they deal to me in that hand will be another 4 of hearts. Okay? So once I see an outcome, I will not see it again, and that is without replacement. With replacement means even if I see an outcome, it's possible for me to see it again later. So if I'm flipping a coin 10 times, if I see heads, I can still see heads again on a later flip. So that's with or without replacement. So without replacement means that once I see an outcome on an experiment, I will not see it on a later experiment. With replacement means that I can see the same outcome multiple times. Does order matter? So let's see. Let's say I have a club and I'm going to choose 2 people. The first person is going to be the president and the second person is going to be the vice president. So there, that would be a case of in which order matters. The experiment, there would be 2 experiments, one of them choosing a person. In that case, I have 10 club members. There would be 10 distinguishable outcomes. And I would pick a person and they would be the president, and they would pick a second person and they would be the vice president. So the order matters. If I pick Alice and Bob, Alice is the president, Bob is the vice president, and that's distinguishable from choosing in the other order, choosing Bob first and he's the president, and choosing Alice second and she's the vice president. That's distinguishable. Okay? So the result of the first experiment is distinguishable from the result of the second because one of them is for president and the other one is for vice president. On the other hand, I could say, well, I have a group of 10 people and I'm going to pick 2 representatives, and they're both representatives. There's no different types of representatives. They're just going to go to some, national event and represent our club there. There, it doesn't matter if I pick Alice and then Bob or Bob and then Alice because they're both just representatives. So having a team of Alice and Bob as representatives wouldn't matter who gets chosen first and who gets chosen second. That would be an example of order not mattering. So if I'm going to make a sequence of numbers, order matters there. If I'm going to make a set of numbers, order doesn't matter there. So that's our kind of canonical example of order matters versus order doesn't matter. Okay? We have some, in the squares here, some other examples. So if I'm dealing cards, order doesn't matter, right? So I take a deck of 52 cards and deal you 5 cards from there. I'm not going to replace the cards. I'm going to give you one and then give you the second one without putting the first card back in. So there's no replacement. And order doesn't matter because it doesn't matter what order you get the 5 cards in. The 5 cards are the 5 cards. That's your hand. So the hand that you end up with doesn't matter if I give you 4 of hearts and then 5 of hearts or the other way around. So their order doesn't matter. Same thing for picking subsets. I'm gonna choose an element to be in the subset, and then I'm going to choose a different element to be in the subset, and I can't choose an element to be in the subset more than once, because an element is either in the set or not. Okay. So there's no replacement there, and if I pick 1 and 2 and 2 and 1, it's the same set, because order doesn't matter in sets. Okay. So we'll get to this balls and bins example later. This is kind of the only example I could really think of with replacement and order doesn't matter. We'll talk about that more in another lecture. But I could have repeated coin flips. Right? So that's with replacement because I could see heads more than once. So heads and tails would be outcomes, and I could see them more than once. And order matters because heads tails is a different outcome than tails heads. And I could also see like in some kind of competition, right? So I have Zydrunas Savicus and Brian Shaw, and they're competing in, say, the Atlas Stones and the Super Yoke, right? And then my experiments would be each individual event. So the Atlas Stones would be one experiment, and then the outcome would be a winner, either Zydrunas Savicus or Brian Shaw. Right? And so, I could say for the Atlas Stones, Zydrunas Savicus won, and then for the Super Yoke, Brian Shaw won. And then I would have Zydrunas Savicus for the first experiment and Brian Shaw for the second, and order would matter there because who won which event would make a difference. Okay. So their order matters because the first outcome, Zydrunas Savicus, is telling me who won the Atlas Stones event. Okay. And so order matters, and I can have with replacement because it's possible for Zydrunas Savicus or Brian Shaw to win both. So once I see Zydrunas winning the first event, he could still win the second event. So I could have an example of order matters, but there's no replacement is who won first place in the competition and who won second place. So you can't have the same person winning first and second place. Okay, so who won first and who won second matters, so their order matters. There's no replacement. I'm going to say, well, Zydrunas Savicus won first place. I'm not going to see his name again when I go to look and see who won second place. So that's my attempt to explain kind of the different combinations here. Okay, so these are our ingredients, R and N. Order matters, yes or no, with or without replacement. Okay, so this is our chart. We're going to have these 4 outcomes, and we're going to come up with formulas in terms of R and N based on which of these 4 combinations we're in.